All right, greetings YouTube, greetings scholars. We're continuing chapter 3 for College Algebra on logic from Blitzer, Thinking Mathematically. And here we're going to be working on section 3.6, negations of conditional statements and De Morgan's laws. So a few objectives here. One, we like to write the negation of a conditional statement. And two, we like to use De Morgan's laws. The negation of a conditional statement, P implies Q. The truth table that follows shows the negation of P implies Q is P and not Q. Okay, let's see. So we have our two simple statements with our 4 rows. P implies Q is always true except true implies false. We see it here. And then, so the negation means that our final column needs to be the opposite. So they went on and did not Q. And then if we say P and not Q, we get false, true, false, false. So that means that confirms that it is indeed the negation of this. So these columns have opposite truth values. So P and not Q negates P implies Q. So the negation of a conditional statement, the negation of P implies Q is going to be P and not Q. This can be expressed as not P implies Q is logically equivalent to P and not Q. Okay. So write the negation of if too much homework is given, a class should not be taken. Okay. So we said what, P and not Q. So I'm just going to make a little note of that. All right. We said that the negation of P implies Q is P and not Q. Right? You can almost look at this as like P is true and not Q is true, which means that Q is false. And remember, we said that true implies false is the only times that it's false. That might be a bit extra, but you know, this is good enough for here. So if too much homework is given, a class should not be taken. So we can let P be too much homework is given. We can let Q be, I guess, a class should be taken. Let's write that out. Homework is given. Too much homework is given. I'm going to abbreviate it. Okay, Q is going to be a class should be taken. I'm just mimicking what we did in the previous example, in the previous section. So then in symbolic form, this would be P implies not Q. So if we have P implies not Q, and we want to negate this, so then that should be P and not Q. In other words, P and Q. So then the negation would be too much homework is given and the class should be taken. And let's see. I don't know why it keeps doing that. So too much homework is given and the class should be taken. Okay. So I think they got the same thing. You see the P and Q there, and then we have it written out. Okay. So the conditional statement P implies Q, the contrapositive is equivalent to not Q implies not P. And then the converse and inverse is not equivalent to Q implies P and the inverse, right? And so the negation of, so this is just like a summary of what we've kind of been experiencing. So we explore the contrapositive, the converse and the inverse, and the negation of the conditional statement. Okay. So then the Morgan's laws, if we have the negation of P and Q, it's kind of like you distribute, right? So it's like P becomes not, that flips, and that becomes a not, right? So the negation of P and Q is going to be not P or not Q. And it's a similar thing here. Everything flips. Everything flips. Okay. So proof of the first law is shown in the truth table. So the negation of P and Q, and if everything flips, notice that they have the same truth value, final truth column. Okay, and you can pause it and work it out to verify. So De Morgan's law is a negation. So De Morgan's law, the negation of P and Q is equivalent to not P or not Q. To negate a conjunction, negate each component and change and to or. To negate a disjunction, negate each component statement and change or to and, right? So basically everything flips. Man, this is like a really short section. I love it. Write the negation for each of the following statements. All students do laundry on weekends and I do not. So the opposite of all is some. Some students do laundry on the weekends or I do. Some students, I forgot the do not. Some students do not do laundry on the weekend or I do, right? So right there. We negated the all, but we forgot to negate the do laundry, right? Okay. We might have one more. Okay. Some college professors are entertaining. So the opposite of some is none. So no college professors are not entertaining. And I'm not bored. Now I negated the entertaining right there, right? The opposite of some is none. So I said no college professors are not entertaining and I'm not bored. No college professors are entertaining. See, that now they remain consistent there. So no college professors are entertaining and I'm not bored. That's the only thing I keep messing up on. Okay, so with that, we're going to end the session here. And from one beautiful mind to another, enjoy your time. I'll see you next time. Take care. Peace.